November 30th marked the end of hurricane season here in the United States, but this past August and September were extremely active in the Atlantic basin. With Irma, Harvey, and Maria all in the news, it may have seemed like the tropics were more active than ever. My name is Dakota Smith, and I am here to tell you why it was so active and whether or not we've seen this before. To really understand the tropics, let's get some definitions down first. Tropical cyclones or tropical systems are large areas of thunderstorms spinning around a center of low pressure. These types of storms originate across the globe, but they're called different things in different areas. Here in the United States, in the Atlantic and East Pacific basins, they're called hurricanes. In the West Pacific, they're called typhoons. And in the Indian Ocean, they're called cyclones. But they're all the same thing. They're also called different things at different levels of intensity. For instance, hurricanes start as tropical depressions, strengthen into tropical storms, and then eventually strengthen into hurricanes. There's also different categories of hurricanes, ranging from 1 to 5. 3 or higher are considered major hurricanes with wind speeds of excess of 110 miles per hour sustained. You've probably noticed that you've seen hurricanes in the news more often in late summer and early fall. That's because hurricane season starts on June 1st, peaks in mid-September, and then ends on November 30th. Now, tropical systems can happen at any time of the year, but the vast majority of them happen from June 1st to November 30th. This is mainly because tropical cyclone formation only happens when ocean waters are 80 degrees Fahrenheit or warmer. Now, it can't just be a small patch of ocean, it has to be a large extent and extend at least 150 feet below the surface. This warm water acts as fuel, providing tropical systems with the heat and moisture they need to thrive. But it takes more than just warm water. It takes a conducive atmosphere. When water vapor evaporates from the surface and enters the atmosphere, it has to enter an atmosphere that's conducive for moist convection. Moist convection is basically when air rises and clouds form and precip begins. It's a necessity for any rain shower or thunderstorm. The 3 ingredients to moist convection: 1, lift or air moving vertically; 2, an unstable atmosphere; and 3, ample moisture. So to start, we need air moving vertically. For tropical systems, this is commonly provided by pre-existing storms exiting the African coast into the Atlantic Ocean. Now, once we have this lift, next we need an unstable atmosphere. This exists when the air rises and continues to rise without anything externally forcing it. The opposite is a stable atmosphere, where air initially rises and then returns to its original position. The final ingredient is, well, moisture. A moist atmosphere allows rising air to cool and condense, forming clouds and precipitation. So now we have an extensive area of convection with clouds, storms, and precipitation. The final piece to maintaining this tropical system is low vertical wind shear. Low levels of vertical wind shear surrounding a tropical system allows it to continue to form and strengthen. Vertical wind shear is the magnitude of which the speed and direction of wind changes with height. For example, an atmosphere with absolutely no vertical wind shear has the same wind speed and wind direction just above the surface, 50 feet above the surface, 500 feet above the surface, and all the way up. An atmosphere with a lot of vertical wind shear interferes with the structure of a tropical system and commonly causes it to weaken. As it turns out, vertical wind shear on average is relatively low in September compared to other months. Another reason why it's peak hurricane season. So why am I telling you all of this? Because in August and September of 2017, all of these ingredients came together to produce a chaotic period of tropical activity. Now, every hurricane season, the waters are warm enough for tropical development, but the other ingredients can be missing. Say there aren't a lot of storms exiting the African coast, or there's a lot of vertical wind shear. You're not going to get a lot of storms when that happens. Just like a good cake, it takes the perfect combination of heat, moisture, and ingredients to bake up good structure. To get an idea of how tropical activity varies year to year, let's take a look at Atlantic tropical cyclone frequency since 2000. As you'll see, tropical activity varies markedly year to year, being as active as 2005 with 28 tropical storms, 15 hurricanes, and 7 major hurricanes, or it can be as inactive as 2009 with 9 tropical storms, 3 hurricanes, and 2 major hurricanes. This hurricane season, we had 17 tropical storms, 10 of those becoming hurricanes, and 6 of those becoming major hurricanes. Now, it may seem more active than ever because 3 of the 6 major hurricanes made landfall on United States coastline. this is kind of a big deal. To put this into context, let's look back at the year-to-year hurricane frequency and focus on just major hurricanes that have made landfall in the continental United States. You'll notice a gap. From 2006 to 2016, 11 years, there were 0 landfalling major hurricanes, and now, in 2017, there have been 2. Side note, this does not include Maria because its landfall was on United States coastline, but not in the continental United States. So, what's with this gap? Major hurricanes were around, they just didn't make landfall in the United States. These systems are steered by large air masses, one of which is the Bermuda High you may have heard of, that sits over the Atlantic Ocean. For 11 years, these air masses kept major hurricanes off the United States coastline. Now, interestingly, in 2016, Hurricane Matthew almost broke the streak, but was downgraded to a Category 2 hurricane, which is one category below major status, right before landfall. Finally, let's quickly talk about global warming and its impact on tropical cyclone development. So the current consensus is that hurricane and tropical cyclone frequency probably won't increase as global temperatures rise. There are other things about hurricanes and tropical storms that will be influenced by global temperature rises, including rainfall intensity, storm surge, things like that, but that warrants an entire video in itself. To sum it up, the high level of tropical activity we saw this year was not unprecedented. Now don't get me wrong, August and September were super active in the tropics, and a lot of these storms did impact land relative to other years. But when the Atlantic is warm and the atmosphere above the Atlantic is primed for tropical development, you're going to have a busy season. So it may seem like the tropics are more active than ever. It was just an active year during the peak of hurricane season. Thanks for listening.